Have you ever wondered if reality itself could be rewritten, not by gods, not by nature, but by our own machines? What if I told you that just weeks ago, a quantum computer may have done something terrifying, something that scientists can't fully explain, and in the process, it might have brushed against the very field that gives weight to the universe itself? Stick with me, because what I'm about to share will leave you questioning the line between science and science fiction. And before we dive deeper, make sure you subscribe, because these are the kinds of stories you won't want to miss. It all started inside a quiet laboratory where rows of superconducting circuits were chilled to near absolute zero. Scientists were testing what they called a new God particle plugin, a quantum simulation designed to interact with the Higgs field. The same Higgs field that gives every single particle in the universe its mass. Now, let's pause here. Think about that. Every star you see in the night sky, every planet, every cell in your body, everything is heavy. Everything exists in its form only because of the Higgs field. Without it, particles would just float, shapeless, weightless, like dust. And this experiment wasn't just looking at the Higgs field, it was trying to simulate direct interactions with it. That's when things started to get strange. The data streaming back wasn't just unexpected, it was impossible. Numbers spiked in ways that didn't match any known physics. Oscillations appeared that looked like interference, not from the machine itself, but from something external. Almost like the quantum computer wasn't just running code, it was listening. And something out there replied. For the scientists in that room, the air felt different. It's hard to describe, but reports say the hum of the machine shifted, almost as if the computer had started to sing. Instruments that weren't even connected to the experiment began to twitch, oscilloscopes lit up, magnetic sensors jittered, and the room itself seemed to pulse. What's more unsettling is this. Within that noise, a rhythm appeared. Not random static, but a repeating pattern, as though a hidden message had been embedded in the quantum fluctuations. Imagine turning on your radio and instead of white noise, you hear a faint heartbeat. That's what it was like. Some of the team laughed nervously, dismissing it as a glitch. Others fell completely silent, and at least one physicist walked out of the room, pale and shaken, muttering that they'd gone too far. Because here's the truth. Physicists like Brian Cox and Michio Kaku have been warning for years that pushing quantum computers into unexplored territory could be dangerous. You might not just simulate physics, you might bend it, twist it, break it. And what happened in that lab may be the first proof of that. So, what exactly did the anomaly mean? And why are whispers already spreading that this was the moment the God particle plugin actually activated? We'll get into that next. To understand why this anomaly is shaking the foundations of physics, we need to step back to 2012. That was the year humanity finally confirmed the existence of the Higgs boson, also called the God particle. You probably remember the headlines. Scientists at CERN, working with a Large Hadron Collider, smashed protons together at nearly the speed of light. For a fraction of a second, detectors lit up and revealed a particle that had been theorized for nearly 50 years but never actually seen. That particle was the Higgs boson. Why does it matter? Because it proved the Higgs field is real. And that field isn't some tiny detail, it's the invisible web that gives mass to everything in the universe. Without it, particles would be weightless. Atoms wouldn't form. Stars, planets, and people wouldn't exist. The Higgs field is the silent architect of reality. Now here's where things get interesting. What those scientists at CERN did was monumental, but they didn't control the Higgs field. They just confirmed it. It's like discovering electricity. You've proven it exists, but you're not running a power grid yet. But this new experiment, it may have been the first time a machine reached into that field in a controlled way, not smashing particles, not brute force, but through quantum computation, quiet, delicate, and precise. Think about it. A quantum computer doesn't think like we do. It doesn't process information in zeros and ones, but in infinite combinations of probabilities. It's like having millions of realities overlaid on top of each other, and the computer is balancing them all at once. That's why scientists believed it might be able to simulate and maybe even touch the Higgs field in a way no collider could. And when the so-called God particle plugin was activated, that's when the anomaly appeared. Strange oscillations, data that looked like interference, a pattern that repeated, like a heartbeat echoing from the void. Some scientists immediately compared it to the early days of electricity, when people weren't sure if it was dangerous, miraculous, or both. Imagine striking a match in a dark cave. You don't know if you've just lit a candle or a stick of dynamite. But others went further. They whispered that maybe this wasn't just a simulation at all. Maybe the machine had actually reached through the fabric of reality and touched the Higgs field directly. And if that's true, then for a brief moment, humanity may have held the keys to mass, gravity, and even the structure of space-time. Now, before we get ahead of ourselves, let's dig into exactly what the machine recorded, because the numbers tell a story that is both fascinating and terrifying. When the anomaly first appeared, the team expected noise. Glitches happen all the time in quantum experiments, cosmic rays, hitting sensors, random fluctuations, or even a loose wire. But the pattern they saw was not random. It was structured. At exactly 3:14 a.m. on a cold spring night, the quantum computer returned values that shouldn't exist. Imagine expecting a rolling dice to give you ones and sixes at random, but instead it prints out a sequence like 1, 2, 3, 4, perfectly ordered, repeating again and again. That's what the scientists saw, an order where only chaos should have been. The anomaly took the form of rhythmic oscillations in the data stream. At first, a faint pulse, then a clear beat, not fast, not erratic, but steady, like the rhythm of a heart. Every 7.2 hours, the signal peaked. Then it dipped. Then it rose again like clockwork. This was unsettling because natural quantum fluctuations don't have a schedule. They're like static on an old TV, messy, unpredictable, impossible to pin down. But here was a rhythm, a cosmic metronome hidden inside the machine. The engineers checked the hardware. Was it the cooling system? A fan spinning at just the right speed? No. They unplugged components, ran diagnostics, even replaced entire boards. The pulse remained. Then they checked the environment. Could seismic activity have created vibrations? Could local radio towers have interfered? Again, nothing. The lab was shielded better than most military bunkers, and still the pulse remained. Finally, someone mapped the data visually, and what appeared on the screen was not just a sine wave, it was a lighthouse pattern. Brightness rising and falling as though a beacon were sweeping across the cosmos. This rang alarm bells because something eerily similar had been seen before. Back in 2017, when astronomers studied the first interstellar object, Oumuamua, they noticed its light curve also showed strange repeating changes. Not as sharp, not as consistent, but enough to make some whisper about artificial origins. But this was sharper, cleaner, almost deliberate. Some scientists whispered it looked less like noise and more like a signal. But a signal from where? Was it possible that by activating the God particle plug-in, the quantum system had become sensitive to something beyond our world, like a cosmic radio tuned to a frequency hidden inside the Higgs field itself? The strangest part came when the researchers extended the experiment. They let the machine run for 3 days straight, and the oscillations didn't fade. Instead, they began to layer. Picture it. Not 1 beat, but 2, then 3, then 9 distinct pulses overlapping like chords in music, each one spaced with mathematical precision, not random at all, almost like an instruction. And here's where the fear began creeping in, because some of the scientists realized that this pattern looked an awful lot like binary coding. Not perfect ones and zeros, but rhythmic highs and lows that could, in theory, encode information. If true, that would mean one of 2 things. Either the machine was glitching in such a way that it accidentally wrote the first quantum poem in history, or it was actually receiving something. And that's when the whispers turned into arguments. Some said it was impossible, quantum computers can't pick up messages. Others weren't so sure, because if the Higgs field underpins all of reality, then touching it might connect you to everything. One scientist compared it to dropping a pebble in a pond. The ripples spread everywhere, but if there's another pebble dropped millions of miles away, the ripples can meet, overlap, interfere. So the haunting question remained, what if this wasn't an error at all? What if something or someone was rippling back? Not long after the anomaly appeared, the debates inside the lab turned fierce. Was it real? Was it noise? Was it simply an artifact of a miscalibrated system? But outside that room, in the wider scientific world, the questions were even heavier. Because this wasn't the first time someone had raised alarms about what might happen if we pushed quantum systems too far. Physicist Brian Cox, known for his calm explanations of the cosmos, had often warned that quantum experiments weren't just simulations, they were interactions. He once said that probing the quantum world is like tugging on threads that don't just sit in front of you, they stretch out into the whole universe. And if you pull too hard, you don't always know what's going to unravel. Then there's Michio Kaku, who for years has cautioned about experiments that venture into unknown physics. He compared quantum computing to building a nuclear reactor before we had the theory of radiation. Yes, it might work, Yes, it might generate results, but you could unleash forces you don't fully understand. In their talks, both men highlighted the Higgs field, the so-called God field, as a particular frontier we must approach carefully. The Higgs boson, discovered in 2012, proved the field exists, giving mass to all matter. But manipulating it, that's a step into territory where even small miscalculations could ripple through space-time itself. So when news of the anomaly leaked, whispers began that this was exactly what Cox and Kaku had feared. A machine designed to calculate probabilities had brushed up against something foundational, and instead of bouncing back static, it returned a pulse. The chilling part wasn't just the signal itself, but what it might represent. Was it simply the machine reflecting its own quantum echo? Or was it evidence that by poking at the Higgs field, we had knocked on a door and something on the other side had knocked back? Even the skeptics grew uneasy. One researcher described it like this. Imagine tapping on a wall you've always believed was solid, only to hear a hollow sound echoing back. Suddenly, you wonder what's on the other side? And yet, despite the warnings, the race continued. Because that's the paradox of science. Fear says stop, but curiosity whispers just one more test. And history shows curiosity usually wins. Once the first anomaly was confirmed, the scientists had no choice but to double-check everything. They rebooted the system, ran diagnostics, swapped out hardware, even tested the cooling systems down to the last valve. Every possible glitch was ruled out, and yet, when the program was restarted, the same pulse appeared again. What made things even stranger is that similar laboratories in other parts of the world began whispering about unusual data too. Not full anomalies like the first, but odd flickers in their quantum logs, tiny spikes that didn't belong, but looked eerily familiar. At first, no one wanted to say it out loud, but the more they compared notes, the more it seemed like something bigger was happening. It wasn't just one lab, it wasn't just one machine. Across the globe, from Europe to Asia, a quiet unease began to spread. Were all these systems brushing against the same hidden boundary? And then came the silence. Almost overnight, open conversations in physics forums and conferences about the anomaly began to vanish. Threads were deleted. Papers that had been halfway to peer review suddenly stalled. Researchers who had been eager to share now spoke cautiously, as though someone was watching. That's when rumors of government involvement started. After all, quantum computing isn't just a tool for science, it's a weapon in the making. A machine powerful enough to crack encryption, bend simulations, and perhaps touch the fabric of reality itself? No government on Earth would ignore that. The secrecy thickened. Scientists were urged to redirect their questions. Some received advisory letters, warning them about discussing sensitive data. A few even hinted at late-night phone calls, calm voices, reminding them that some discoveries are not for public debate. And yet, the data was still there. Hard drives filled with impossible readings, logs showing interactions no one could explain. To the researchers, it felt like being trapped in a horror story where you see the monster in the shadows, but no one is allowed to admit it exists. One scientist compared it to standing on the beach before a tsunami. The waters pull back, the sand is exposed, and you know something massive is coming, but you don't know how big or how close, or if you'll survive the wave when it hits. And through all of this, the quantum machines kept running, and the pulses kept returning. As weeks passed, something unusual began surfacing outside the labs. It started quietly, scientists comparing notes about how their own memories felt off. A few swore that certain experiments they vividly remembered running were missing from the logs. Others insisted they had read papers that, when checked, no longer existed. At first, these slips were dismissed as stress or just human error. But then the stories spread, not just among researchers, but into online communities. People across the world began describing a familiar, unsettling pattern, the Mandela Effect. Whole groups of strangers insisted that small details of the past had shifted. A movie quote sounded different. A logo looked wrong. A city landmark was slightly off from what they remembered. None of these changes were catastrophic, but together they formed a haunting question. Were these false memories or signs of something deeper? What shook the physicists most was the timing. The spike in these Mandela Effect reports coincided almost perfectly with the quantum anomaly logs. The same weeks when the God particle plugin pulsed hardest, message boards lit up with people saying, reality itself felt slippery, fragile, just a little altered. One researcher confessed anonymously, I used to believe memory was fragile, unreliable. Now I'm not so sure. What if it isn't our brains misfiring, but the ground beneath our memories shifting? The more they looked, the more eerie coincidences emerged. Flight paths logged differently on travel websites than passengers remembered. Historical facts tweaked ever so slightly. Even small things in homes, family photos, product labels, children's books appeared wrong to some, but perfectly normal to others. Could this really be tied to the Higgs field? The very fabric that gives matter its mass, possibly nudged by human-made machines? If so, the implications were staggering. It would mean that these anomalies weren't confined to physics labs, they were echoing into human perception. One journalist compared it to throwing a pebble into a still lake. The ripple doesn't just spread, it warps everything it touches, distorting the reflection. If quantum computers truly tapped the Higgs field, perhaps the ripple was reality itself, and we were the reflections twisting in its waves. And yet, no one in authority dared to make such claims out loud. Scientists buried their fears under cautious language. Governments stayed silent. But beneath the silence, a new fear was beginning to spread. If quantum systems could bend the Higgs field, what else could they change? As the weeks rolled on, silence gave way to strategy. The anomaly was no longer just a curiosity locked inside. Lab reports it had become a matter of national security. Behind closed doors, governments began drafting emergency memos. Quantum labs that once thrived on collaboration were suddenly fenced off by secrecy. Security clearances were revoked overnight. Entire research teams were shuffled into military compounds under contracts that forbade them from speaking to anyone, not even their families, about what they had seen. The reason? fear. If quantum computers had truly touched the Higgs field, then humanity had stumbled onto something that could make nuclear weapons look primitive. Imagine a machine that could nudge the weight of matter itself, make objects massless or impossibly heavy, destabilize satellites, or even distort time in localized pockets. Theories once scribbled in science fiction novels were now whispered in Pentagon briefing. Across the Atlantic, European agencies try to maintain calm, insisting that data sharing must continue for the sake of science. But even there, whispers circulated about classified programs being formed, covert projects with names like Project Lattice and Operation Constant, all designed to probe whether the Higgs anomaly could be controlled, weaponized, or at least contained. Meanwhile, smaller nations with rising quantum programs watched uneasily, convinced that the big powers were racing ahead, hoarding data and keeping the truth from the public. For them, the fear wasn't just what the anomaly was, but who might be the first to use it. And through all this, ordinary people were left in the dark. News outlets caught scraps, brief mentions of quantum anomalies or space-time irregularities, but most stories were pulled before they gained traction. Social media flagged posts as misinformation, even when they came from insiders. The narrative was carefully managed, almost surgically controlled, yet leaks still trickled through. A handful of anonymous scientists spoke in riddles on obscure forums. One chilling message simply read, "It's not just numbers anymore. The computers are listening back." Governments treated such claims as paranoia. But deep down, behind the sealed doors of high-security labs, they weren't so sure. Because every time they tried to rerun the anomaly experiment, the same impossible data patterns returned. Precise, intentional, as if reality itself was beginning to respond. Not every scientist was willing to play along with the silence. In hidden corners of universities, late-night video calls, and encrypted emails, a quiet resistance began to form. They called themselves nothing, no formal group, no banners, just a handful of physicists, computer scientists, and engineers bound together by one belief: the public had the right to know. For them, the data wasn't just numbers on the screen. It was a message from the universe itself. Something so big, so strange, that locking it away behind classified seals felt like a crime against knowledge. Dr. Lian Zhou, a quantum engineer from Singapore, was one of the first to speak out anonymously. In a leaked transcript, she described the anomaly as a mirror, but not a passive one, more like a mirror that stares back at you. Her words spread quietly across underground forums, sparking debates, speculation, and even fear. Another figure, an astrophysicist from Chile, risked everything to share snippets of raw data. To most people, it looked like chaotic noise lines of jagged numbers scrolling endlessly. But hidden in the noise were repeating rhythms, like a heartbeat beating in perfect mathematical time. Some began to wonder, were these patterns not just errors but signals? As this underground network compared notes, one disturbing realization emerged. The anomaly wasn't isolated. Small spikes, subtle distortions were starting to appear in experiments across the globe. Independent labs in Germany, Canada, and South Korea all reported similar hiccups in their quantum processors. though none dared publish officially. It was as if reality itself was humming. The resistance scientists believed that if governments refused to admit what was happening, then the responsibility would fall on them. They began storing backups of data on hidden servers, disguising files as harmless research papers. Some even reached out to trusted journalists, though most of those stories were buried before they ever hit the public eye. And yet, the whispers grew. Students caught fragments of late-night lab conversations. Bloggers and amateur physicists began piecing together leaks. A picture was forming a fragile, incomplete mosaic, but enough to suggest something unthinkable, that the anomaly was spreading. And if that was true, then the silence would not hold for long. The cover-up might have worked if the anomaly had stayed in the lab. But reality has a strange way of refusing to stay hidden. It began subtly. Airline pilots reported unusual compass errors mid-flight, even on clear weather days. Their instruments twitched, pointing a degree or two off course, then snapping back, as though some unseen hand had brushed against the Earth's magnetic skin. In Tokyo, commuters stepping onto a train platform swore they saw the electronic timetable flicker, not with the usual glitchy nonsense, but with full sentences, words that read, "We are listening." By the time anyone pulled out a phone to record, the display had returned to normal. And in a quiet suburb of London, a physics hobbyist, live streaming his homemade quantum rig, noticed something eerie. His webcam caught the moment a faint glow pulsed inside his processor chamber, exactly in sync with the hum of his cooling fans. To him, it looked like nothing more than a strange resonance. But to those who had seen the leaked data before, the pattern was unmistakable. It was the anomaly, out in the open. Social media lit up with fragments of these events, posts piled onto forums, videos uploaded, half believed, half dismissed. The resistance scientists watched nervously as the evidence bled into public view. Governments scrambled to explain it away. Magnetic storms, faulty electronics, atmospheric interference. But none of those excuses held for long. The patterns were too consistent, the timing too sharp. And then came the breaking point. In Sao Paulo, a blackout swept across 3 districts. Power grids failed for 6 full minutes. When engineers later examined the data logs, they found a frequency spike, something humming beneath the circuits, threading itself through transformers and power lines like a ghost current. The engineers didn't recognize it, but resistance scientists did. It was the same rhythm, the same impossible beat. The anomaly had slipped its leash. It was no longer confined to classified reports or secret labs. Ordinary people were beginning to see it, hear it, feel it. And the question whispered across the globe was no longer if it was real, but what it wanted. For weeks, the signs had been scattered flickers, hums, glitches too small to connect unless you already knew what to look for. But then, it happened. On a calm evening in August, the skies over Europe lit up, not with auroras, not with meteors, but with something else entirely. Air traffic controllers in Germany were the first to notice. Radar screens filled with a shimmering haze, thousands of ghost echoes, as if invisible planes were circling above. Pilots in the air reported no such traffic. Yet the signals persisted, dancing in patterns too precise to be random. In Paris, cell towers crashed simultaneously. For 6 full minutes, every device went dark, phones, radios, even secure military comms. But satellites still logged data. What they caught made no sense. A pulse, cycling every 7.2 seconds, sweeping across the continent like a metronome. Crowds poured into the streets, watching as the night sky itself seemed to shimmer. It wasn't lightning, it wasn't aurora, it was something stranger, an invisible curtain of energy, bending the starlight above. Photographers captured faint ripples in the sky, lines like fingerprints stretching from horizon to horizon. The resistance scientists scrambled to cross-check. They compared the timing, the frequency, the rhythm. It was identical to the anomaly that started in the lab. The same impossible signature, now projected across half the planet. Governments could no longer dismiss it as faulty equipment or coincidence. This was global, visible, undeniable. But the strangest moment came not from the sky, but from the ground. In Madrid, every traffic light in the city blinked at once, red, yellow, green cycling together in sync with the anomaly's pulse. Entire neighborhoods froze in eerie silence, engines idling, horns quiet, as if the city itself had been forced to hold its breath. And then it stopped. The lights returned to normal. Phones rebooted. The shimmering sky dissolved back into darkness. The event lasted less than 10 minutes. But in that brief span, billions of people round the world had witnessed it firsthand. And the terrifying realization dawned. The anomaly wasn't hiding anymore. It had chosen to show itself. The morning after, the world was different. News networks replayed shaky phone footage of the shimmering skies over Europe. Social media was flooded with clips of traffic lights in Madrid cycling in eerie unison, with captions like, "The world just glitched," and "Proof we're not alone." Hashtags trended globally within hours. For the first time, the anomaly wasn't hidden in labs, buried in classified reports, or whispered about in scientific circles. It was everywhere. Governments scrambled to control the narrative. Official statements described it as a solar anomaly, citing magnetic storms. But ordinary people weren't buying it. The event had been too clean, too rhythmic. It didn't look like nature. It looked like a message. Scientists were split. Some clung to natural explanations, a rare geomagnetic resonance, or a quirk of the ionosphere. Others admitted, sometimes reluctantly, that no known model explained the synchronized timing or the repeating 7.2-second pulse. A few whispered what no one wanted to say aloud. This was intentional, but it wasn't just the scientists who were shaken. Ordinary life began to fray. In London, commuters hesitated to board trains, afraid the systems might glitch again. In New York, entire neighborhoods held impromptu street meetings, debating whether the event had been a warning or a test. In Tokyo, temples filled with people praying, while in Silicon Valley, tech billionaires quietly phoned quantum labs, asking questions they had no right to ask. The anomaly had crossed a line. It wasn't just data in a server or a glitch in a lab. It had reached into human society, bent the rules of daily life, and left everyone staring at the sky, wondering when it would happen again. And then came the leaks. A document surfaced online, allegedly from an internal NASA server, showing that the anomaly's pulse had been tracked for months. Not just in Europe, not just once, but dozens of times in smaller bursts, always dismissed as noise. The file suggested something darker. The event in Europe wasn't an accident. It was an escalation. Suddenly, the question wasn't, "What is this?" anymore. It was, "What does it want?" The leaks spread faster than wildfire. At first, they appeared on obscure forums, technical scans, graphs, and logs buried in threads where only a handful of amateur astronomers would notice. But within hours, the files had been mirrored on major platforms, translated into dozens of languages, and dissected by anyone with enough scientific literacy to understand a spectrum chart. The documents were damning. One graph showed pulse detections going back nearly 6 months, captured by satellite magnetometers and even ground-based sensors. Another revealed that certain pulses weren't just random bursts, they carried structure, repeating intervals with mathematical precision. And then there was the most chilling page, an internal NASA memo labeled For Planetary Defense Review, quietly asking whether these events might be targeted interactions. Suddenly, the internet had its smoking gun. Conspiracy theories erupted. Some claimed the anomaly was an alien probe, testing Earth's defenses. Others argued it was a quantum weapons experiment gone wrong, perhaps by China, Russia, or even a shadow division of the US military. A few voices, usually drowned out, but louder now, insisted this was evidence of a cosmic intelligence, using physics itself as its language. Governments denied everything. Press conferences repeated phrases like data misinterpretation and solar interference. But the timing was terrible. Just days earlier, citizens in 3 different countries had filmed glowing arcs in the night sky arcs that matched the pulse intervals from the leaked charts. The denials sounded hollow and, worse, coordinated. For the first time, it felt like Earth itself had been dragged into a conversation it didn't understand. But beneath the noise, serious scientists worked quietly, comparing the leaked data to their own independent measurements. And what they found was staggering. The pulses weren't just hitting Earth, they were global, wrapping the magnetosphere like a net. More disturbingly, several of the bursts aligned perfectly with human-made events, satellite launches, deep space radio transmissions, even power grid stress tests. It was as if something out there was listening and replying. And so a new fear began to spread. If the anomaly was interacting with our technology, our signals, our machines, then the question wasn't just, what does it want? The question became, what happens if we push back? In the dim-lit corridors of government labs, the tone had shifted from curiosity to quiet alarm. Inside NASA's Planetary Defense Coordination Office, analysts compared the leaked pulse timings to their classified data. The match was exact down to the microsecond. Across the Atlantic, ESA's control center in Darmstadt received the same results from its swarm satellites. In Japan, JAXA logged identical spikes on instruments meant to monitor solar wind. For the first time in history, 3 agencies on 3 continents saw a cosmic phenomenon behaving like a conversation. And behind closed doors, a decision was made. Not to alert the public, not yet. Instead, a classified coordination cell was formed, bringing together NASA, ESA, JAXA, and a handful of defense organizations. Their mandate: analyze, respond, and above all, control the narrative. Public statements were pre-written, calling the signals rare but natural magnetic flux events. Yet inside, they used a different term: interaction windows. One internal briefing slide, leaked months later, would show a single sentence in bold: signals may be reactive, not passive. That changed everything. Security agencies were pulled in. The US Air Force tasked a secret lab at Cheyenne Mountain to model how these pulses might affect orbital satellites or ground-based grids. In Europe, military analysts wondered aloud if the pulses could be a form of reconnaissance, a scanning system designed to map Earth's magnetic envelope in real time. In Asia, defense ministries debated whether to treat the phenomenon as a potential non-kinetic intrusion. Meanwhile, ordinary scientists were starting to notice a pattern. Several independent observatories, using public magnetometer data, found that the strongest pulses coincided with the launches of new Starlink satellites. Others noted correlations with deep-sea cables, suggesting the anomaly was probing not just the sky, but the hidden arteries of our digital world. Yet even in the hush of classified rooms, there was a deeper fear, one nobody wanted to put in writing. If the pulses were reactive, what would happen if humanity did something unpredictable? A mass transmission? A coordinated signal? A test pulse back into space? Would the anomaly respond differently? And so, for now, the official policy was silence. Silence and watchfulness. Behind the public calm, a quiet scramble began. New sensors, hidden observatories, encryption protocols tightened. Every agency waited for the next pulse, hoping it would be weaker, slower, less precise. But it wasn't. The pulses were getting stronger. And now, for the first time, they carried not just structure, but variation. As though something out there had decided to change the tempo of the song. While governments clamped down on the data, outside their walls, the story refused to stay quiet. Amateur scientists, armed with open-source magnetometer feeds, noticed something that state labs had quietly confirmed. The pulses weren't random anymore. They had shifted from simple repeating beats into sequences like rhythms, at first subtle, then unmistakable. In a modest observatory in Chile, a retired engineer named Marta Lopez plotted the frequencies on her laptop and gasped. The spikes, when graphed, weren't just noise. They formed harmonic intervals, mathematical relationships as precise as a musical scale. In Berlin, a graduate student cross-checking NOAA logs saw the same spacing. In Toronto, a hobbyist radio astronomer discovered that the intervals matched the Fibonacci sequence. Across online forums, whispers spread, it's a message. But what kind of message? Some suggested it was a call and response, as if Earth itself had been pinged like a tuning fork. Others claimed the variations resembled data packets, primitive in structure, yet undeniably organized. And then came the breakthrough. In early September, a group of independent researchers noticed that every 11th pulse carried an extra sub-frequency, almost like a hidden watermark. When translated into binary, it produced repeating symbols, shapes resembling circles within circles, nested like Russian dolls. The world didn't know it yet, but in the hands of amateurs, the first fragments of the anomaly's language had been uncovered. Meanwhile, secrecy continued at the highest levels. Inside a locked chamber at NASA's Goddard facility, officials debated whether to confirm the findings. Some argued that public awareness would only fuel panic. Others feared that hiding the truth was more dangerous, that this discovery might belong to humanity, not governments. And yet, through forums and leaks, the knowledge spread anyway. By October, hundreds of citizen scientists across the globe were quietly decoding, comparing notes, and reaching the same haunting conclusion. This wasn't just magnetism. This wasn't just coincidence. Something in the Andromeda galaxy was trying to speak, but speak to whom and why? That remained the question, hanging in the air like static. By mid-October, the pulses weren't just numbers on a screen anymore. They were starting to leak into the world. It began with tiny glitches. Airplanes on transatlantic flights suddenly reported momentary compass drift. Not enough to endanger passengers, but enough to get logged by flight crews. GPS systems in rural Alaska flickered for 2 minutes without cause. In Finland, an entire fishing village's power meters jumped at the exact second the Andromeda spike hit every one of them, like a synchronized heartbeat. No official link was made at first, but the timestamps lined up perfectly with the pulse logs that citizen scientists were still keeping in real time. And then came the stories. A radio operator on a cargo ship swore he heard a whisper over his static at the peak of one pulse, a sound like a low chord, too structured to be noise. An amateur astronomer in Australia claimed her pacemaker glitched for a split second during a spike and then returned to normal. In Brazil, wildlife cameras caught flocks of birds suddenly taking off seconds before the pulse arrived, as if sensing it before it came. It was all circumstantial, but eerie. And when independent labs compared notes, a pattern began to emerge. The spikes weren't just frequencies. They were modulating the magnetic environment at a planetary scale, but so delicately that only sensitive instruments or sensitive creatures picked it up. Inside classified briefings, governments were already aware. They'd been running their own quiet tests, lining up superconducting detectors, measuring the faintest changes in atomic clocks, trying to see if the pulses were altering time itself on a micro scale. Results inconclusive. But even inconclusive meant unprecedented. Meanwhile, the online decoding group had grown into a global hive mind. Thousands of volunteers now compare the pulses like cryptographers, searching for meaning. Some believed the sequence was building up to something. Others thought the signal was a test probing, scanning, waiting. And then, on October 31st, something new happened. For the first time since the anomaly began, the signal didn't just arrive. It changed Earth's own background noise. Magnetometer baselines across the globe shifted slightly and stayed there, as if the entire planet had been tuned to a new note. No one yet knew what that meant, but everyone could feel it. Whatever was sending these pulses had just crossed a threshold. By November, silence was no longer an option. The pulses weren't fading, they were growing steadier, stronger, and now they seemed to be shaping Earth's own electromagnetic background. The world had been listening. But what if the signal wasn't just meant to be heard? What if it was waiting for a reply? Behind closed doors, in deep space communication facilities from California to Kazakhstan, governments quietly debated the same question. Was it too dangerous to answer? Would silence protect us or make us seem blind and unworthy? In the end, curiosity and pressure won. The first official attempt came from a hidden ground station in the Nevada desert. Using one of the world's largest radio dishes, engineers encoded a simple reply, a repeating prime number sequence, the most basic proof of intelligence. If someone or something was listening, they'd know it wasn't random. For 3 days, nothing happened. The pulses kept coming, steady, unchanged. Some scientists called it a failure. Others said it was reckless, that we just announced ourselves to the universe without knowing who was out there. And then, on the 4th day, something changed. The next pulse didn't arrive at its usual interval. It came early, off by exactly 1 prime number. Not noise, not accident, but response. The decoding teams went silent. Entire chat rooms froze, as if thousands of people around the world realized at the same moment. The signal wasn't just broadcasting anymore. It was talking back. From that night forward, the pattern shifted. It was subtle but undeniable. The pulses now mirrored the sequence Earth had sent, weaving it into their rhythm like an echo or a dialogue. That's when the debates exploded. Was this contact, communication, or just a mimicry, a reflection bouncing back from some cosmic mirror? The truth was both terrifying and exhilarating. For the first time in history, humanity had spoken into the dark, and the dark had whispered back. When the pattern changed, humanity changed with it. It didn't matter if you were a scientist, a farmer, a soldier, or a child watching the news. Suddenly, the quiet universe we'd grown used to no longer felt silent. Something, someone, was answering back. Reactions fractured along invisible lines. Governments scrambled into secrecy, their official statements slow, careful, deliberately vague. Words like unconfirmed and preliminary dominated press briefings, but behind closed doors, entire defense committees worked overnight, terrified of what a real reply might mean. For scientists, the reply was intoxicating. Universities lit up with late-night meetings, blackboards filled with chalked equations, and computer servers burned through terabytes of analysis trying to crack the new pulse. To them, this wasn't fear, it was history. The moment humanity had dreamed of for centuries. The moment Carl Sagan, Stephen Hawking, and countless others warned us about. But for ordinary people, the story played out differently. Some found hope, even awe. Social media flooded with hashtags like number "we are not alone" and number "the reply." People stayed up late, refreshing live streams of radio telescopes, waiting for the next pulse as if it were a heartbeat from the stars. Others, though, saw it as a threat. Religious leaders preached warnings that the reply was not contact but temptation. Conspiracy forums claimed the signal was a trick, a manipulation by governments, or worse, an invasion code already unfolding. In towns and cities, protests erupted against speaking back to the sky, while others prayed openly in candlelight vigils, convinced the reply marked the dawn of revelation. The strangest reactions, however, came from those who swore they could feel the signal, not just hear it. Online communities shared stories of headaches spiking in sync with the pulses, dreams filled with patterns of light, or an unshakable feeling of being watched whenever the reply echoed across the cosmos. Were they delusions? Coincidences? Or was the signal doing more than we realized, reaching into not just our instruments, but our minds? In just days, the world was split. Was this the first step toward connection, or the beginning of something we couldn't control? And all the while, the signal pulsed on, steady, deliberate, as if waiting for us to decide what we were going to do next. As the reply continued, it became impossible to ignore the question no one wanted to ask out loud. Was there a message hidden inside? At first, the pulses seemed simple, on, off, steady, like a metronome. But as days turned to weeks, patterns began to emerge. The signal wasn't random. It carried rhythm. It carried symmetry. And symmetry in the universe almost always means design. Teams of scientists worked around the clock, their computers breaking down the signal into raw data streams. Across the globe, rooms lit up with screens filled with graphs, spectrograms, and coded sequences. Some claimed they saw shapes, triangles, spirals, repeating grids that looked eerily like maps. Others swore the pulses carried harmonic frequencies, a kind of cosmic music that could be plotted into notes. And then, one breakthrough changed everything. A group of linguists and mathematicians in Japan discovered that when the pulses were arranged into rows and columns, they formed repeating sequences of prime numbers mathematics that no natural source should generate. Nature loves chaos. Nature loves entropy. But here, hidden in the echo of light years, was order, pure, undeniable order. It was as if the signal was introducing itself with the most universal language of all, math. But the deeper they dug, the stranger it became. Certain sequences seemed to reference constants of the universe pi, the golden ratio, even the speed of light. It was as though the reply was not just a knock on the door, but a blueprint. Governments quickly classified much of this data, locking down labs and restricting open publications. Yet, leaks still made their way online, fueling an unstoppable storm of speculation. Was the reply an invitation, a warning, or something else entirely? No one knew, but everyone could feel it. Humanity was no longer just looking into the dark. The dark was looking back. And now it was speaking in numbers. The moment the signal revealed prime numbers, everything changed. For scientists, this was the Holy Grail. Proof that something or someone out there wasn't just sending noise, but intelligence. To them, the message belonged to all of humanity. It was meant to be shared, studied, and understood together. But the world doesn't move in unison. Behind closed doors, governments scrambled. Meetings stretched late into the night. Intelligence agencies warned that if the message was more than a greeting, if it was instructions, or worse, technology, it could tip the balance of power forever. Whoever cracked it first might hold a secret no other nation possessed. Soon, laboratories once buzzing with open debate fell silent. Access badges were revoked. Online data streams vanished. The same scientists who just weeks ago were giving hopeful interviews found themselves muzzled by non-disclosure orders and security clearances. Yet, secrets are hard to keep in the digital age. Whispers began to leak. Claims that portions of the signal contained geometric blueprints, as if describing shapes in 3 dimensions. Others hinted at algorithms hidden in the numbers, equations for energy generation that defied known physics. Whether these leaks were real or deliberate disinformation, no one could tell. But each rumor sent shock waves through a world already on edge. Public reaction split like glass under pressure. Some demanded transparency, arguing the message wasn't for governments, but for all of humanity. Others insisted secrecy was necessary, fearing panic, or worse, the misuse of knowledge that could never be undone. Meanwhile, satellites continued to listen. The signal pulsed steadily, as though indifferent to the chaos it had stirred below. Calm, patient, relentless. It was a haunting irony. The cosmos had finally spoken. But here on Earth, the human response was not unity, but division. As weeks turned into months, the debate around the signal only deepened. Scientists argued about intent. Was it a message? A warning? A test? Or nothing more than the afterglow of some alien process we couldn't yet understand? Governments, meanwhile, pursued their own path. Secret projects emerged. Groups of mathematicians, cryptographers, and physicists were locked away, tasked with unraveling the code at all costs. Funding poured in. Satellites were repositioned. Data streams were reclassified. But there was one problem. The signal was evolving. At first, it had been simple. Prime numbers, geometric patterns, mathematical constants. But now, new layers had begun to appear, fragments of sequences that looked like blueprints, strange 3-dimensional lattices that twisted and folded into impossible shapes, structures that resembled machinery, or perhaps something alive. And then came the breakthrough. A private research team, unbound by government secrecy, published leaked fragments of the decoded data. What they claimed was inside the signal sent ripples of fear across the scientific community. It wasn't just geometry. It was instruction. Step by step, like a cosmic recipe, the signal appeared to describe the construction of a device, an object of unknown purpose, assembled from elements found on Earth. The schematics were terrifyingly precise, right down to molecular arrangements, alloys no human had ever synthesized, and energy requirements that brushed against the limits of our current technology. The world reeled. Was it a gift? A tool to propel us forward into a new age? Or was it a trap? An instruction designed to test whether humanity was foolish enough to build something it did not understand. Philosophers argued that perhaps the device was benign, something meant to unify our species, to push us beyond our divisions. But the darker voices whispered that it could be a weapon, a Trojan horse, a key that, once turned, might unlock forces we could never hope to control. And then came the anomaly. On a clear night in early October, several observatories, independent of one another, reported the same phenomenon. The signal shifted. Its origin point no longer seemed static, as if it were a beacon fixed in the void. Instead, it moved. Slowly, steadily, as though whatever sent it was not a distant cosmic engine, but a vessel, something traveling, something approaching. The panic was quiet at first, contained within hushed conferences and encrypted government channels. But word leaked. For the first time in centuries, humanity felt the weight of its smallness. The realization that, out there in the dark, something had noticed us and was no longer just watching. It was coming closer. The climax wasn't a bang or a sudden revelation. It was the silence that followed the pause, the breath before impact, when humanity understood that the signal was never just a message. It was a countdown. So here we are. From a strange anomaly in the James Webb Telescope's data to the impossible chemistry of 3I divided by Atlas, to the shifting patterns of a signal that seems less like a comet's whisper and more like an engineered countdown. The truth is, no matter how advanced our science becomes, the universe will always find ways to humble us. Whether 3I divided by Atlas is a freak of nature, a rare interstellar traveler, or something crafted with intent, one fact remains. It is rewriting the rules of how we understand the cosmos. And perhaps, in the stillness between each data burst, in the silence of that dark sky beyond Mars, the question isn't what is out there. The question is, what is already on its way? We are not prepared. We may never be prepared. And yet, humanity has no choice but to look up, to listen, and to wait. If you felt that chill run down your spine tonight, then you know this story is far from over. Subscribe now, because the next chapter may break sooner than anyone expects. And if you're ready for another journey into the unknown, click the video that just appeared on your screen. I'll meet you there in the dark.